Team, we're going to try something a little different this Wednesday. I'm going to pre-record today's lesson, and hopefully we're able to accomplish a little bit more in our short time that we have on Wednesdays. All right, so the purpose of today's lesson, 5.2.3, is to convert quadratic equations from standard form to perfect square form, but without using algebra tiles. The question is, how do we do it without using the algebra tiles? All right, so let's warm up by doing what we've done in the past. Let's use the algebra tiles, and then we'll kind of remove that support, okay? So we start off x squared minus 4x minus 2. Well, I know that I'm making squares, so I know that my length and my width will have to be the same. So I'm going to put 2 here and lay these guys down and put 2 here. All right, now I have these two negatives, and I have to deal with these. I can't just ignore them. But I know that I have to fill these with positives because negative 2 times negative 2 is going to be positive 4. So fill in these with positive 4. And then to sort of deal with these negative 2, we're going to bring over positives to cancel them out. Right? So in total, I just brought in 6 green squares on the left. So I'm going to bring in 6 green squares on the right. Here we go. Okay, so everything is balanced. We've made a perfect square by completing it with 6 singletons. So my perfect square form, x minus 2, because we've got negative 4 to begin with, right? Negative 4x. So x minus 2 squared equals 6. All right, now to solve this equation, we square root both sides. And that leaves us with x minus 2 equals radical 6, and x minus 2 equals negative radical 6. Remember, the square root gives us 2 solutions, one that is positive and one that is negative. All right, add 2 to both sides gives us our 2 solutions. And there we go. All right, so this is what we've done in 5.2.1 and 5.2.2. Let's take a look now. Do we actually need the algebra tiles? So let's do this using the algebra tiles and then see if we can do it using just the area model. So I know that I've got 6x. We're going to split this up evenly, right? 3x here and 3x here. Okay. No problem. We're cruising. What does that look like on the area model, though? How could I do that on the area model? Well, I know that my x squared is going to go here for sure, right? I know it's going to go there for sure, okay? And then we just put 3 x's in each of those. So couldn't I just write 3x, and that'd be the same thing? Okay, now I got to figure out these guys. Well, I've got 2, right? Which is not enough. So I have 2, but I need more. Okay, well, how many more is it going to take? I need 1, 2, 3, 4, 5, 6, 7. Okay, so I needed 7 more. So I had to add 7. Okay, well, in total, that gave me 9, right? So my images are actually the same here. And now I got to worry about the other side. So I added in 7, right? I went from 2 right here, 2, but I needed to get to 9. So I had brought in 7. 1, 2, 3, 4, 5, 6, 7. All right. Now, in an area model, what does that look like? Well, just 7. And then we get the same thing. It's all expressing the same information. An x squared, over here goes with an x squared over here. A 3x over here goes with 3x over here. This 3x goes with this 3x. And this 9 goes with this 9. Pretty sweet, huh? So our final answer, x plus 3 squared equals 7. And now we are in perfect square form without using the algebra tiles, without having to use the algebra tiles.